Square waves. The foundation of a lot of old video game music. Now there's an interesting fact you might know about square waves. You can actually build a square wave entirely out of sine waves. You may even have seen an animation that looks something like what I'm showing here. Anyways, I've always wondered what would happen if you take each of these sine waves and mess with the phase a little bit. What if I randomized the starting angle of each of those little circles? Would it still look like a square wave? Would it still sound like a square wave? Well, the result certainly doesn't look like a square wave at all. However, the sound... Well, that square wave music I played at the beginning wasn't actually square waves. Let me show you the waveform. For comparison, here's a version that's made of actual square waves. They sound nearly identical. Now here's just some plain tones side by side. Yeah, they're nearly identical in terms of sound. So how can these two completely different looking waveforms sound so similar? Well, while you might look at these two waveforms and see two completely distinct waves, this isn't what your ear hears. Your ear hears frequencies and their loudnesses, and the frequencies in those two waveforms are exactly the same. The only thing that's different is the phase. Now I'm gonna play some other square wave music using some of those square wave substitutes. And just for fun, here's the passage sound effect from ZZT. And here's my version without square waves. Now another interesting thing, if you ever looked at an oscilloscope view of some music on YouTube and seen that the square waves aren't very horizontal, well, it turns out that those slanted lines are simply what you get when you take a square wave and rotate it. Not like that though. If you look at the previous diagram with the circles, you can actually take this whole shape on the left and rotate it and get those same slanted lines. And because the frequencies and amplitudes haven't changed, it still sounds exactly like a square wave. So, is this useful at all? Well, for square waves, not really, because they're already pretty optimal. If I keep rotating this shape here even more, the peak amplitude of this waveform goes up. But the loudness is exactly the same, so you can't fit as loud a sound in your audio. In fact, if I add even more terms to this, the peaks will get even taller. However, there are other waves that aren't quite so optimal. For example, the triangle wave can actually be compressed down by rotating it. Anyways, it's pretty unbelievable that you can have two waveforms that look so different and have them sound pretty much the same. Yeah, thanks for watching. I hope you learned something because I sure did. And make sure to casually meander over to the subscribe button and lightly feather it. Be gentle, please. You don't want to break it. Bye.